So now that we've discussed how exactly to create a t-event function, let's talk about how do we use it, or how good is it. So for any program, right, that's out there, right, we could potentially follow these steps, right, of benchmarking, modeling, prediction, validation, and come up with something to model it. But how useful is that going to be? Well, the issue is, right, is it's useful in specific cases. Now, out of the box, what it gives you is a way to directly predict how much time a program will take to run on a given input. That by itself is, of course, very valuable. We can basically schedule ourselves. We can say, okay, I have this input, right? I have 10,000 genomes to process, whatever, and I can predict, oh, hey, that's going to take 2 months to run. That's very nice, right? To know basically how much time it'll take. Of course, there may be some error, but it's still very nice to know. The issue, of course, is that t-event function we predicted, right, or we modeled, is very, very specific, right? So our initial benchmarking took place on some specific computer, right? So it had some version of the compiler installed, some version of the operating system installed. There were specific programs running in the background. There may be specific test sets I used it on. That is all a very, very specific context. And so if we create a model for it, there's kind of an implication that, oh, hey, that model is only valid for that particular context. Now our hope, right, the hope and the dream, right, is that the model we created does generalize to other systems. But a lot of times it won't. Really what will happen, right, is that we have our t-event, right, and the t-event function generally has this form of a times n to the b. Usually the b will be pretty stable between computers, but that a value, right, the constant in front, right, or maybe if there's a coefficient in front, or if there's a constant being added to it, those two things, right, may change between different computers because of differences in software, because of differences in hardware. Which is really kind of annoying, right, and limits basically the scope of when I can use that t-event actually to predict the run times of a program on a given input. What is valuable, right, will always remain valuable is that b value, right, the power. So if I have a couple different methods to solve the same problem, I do this analysis process on all of them, right, and I figure out what their b is, I'll just be able to sort them. So something with a b value of 2 is going to naturally be faster than something with a b value of 3. And you can maybe think about that just in terms of imagining what the growth functions look like. A growth function with a power of 3 is going to grow a lot faster than a growth function with a power of 2. So it lets us categorize these things into our little buckets that we talked about at the beginning of this module. So it can be useful, but the predictions don't always generalize very well. Also, if you've seen benchmarking kind of routines for hardware, right, you realize that these benchmark results aren't even always usable right in the same computer. Yeah, I can just reboot the operating system and all of a sudden I get completely different performance because different programs are running in the background. So it's hard to generalize even between different days, right? I come back the next day and my program behaves differently. So again, these t-events are very, very specific, although that b value does generalize.